Okay, let's look at transformation example 3. It's from the handout that I gave out to you guys either Thursday or Friday, depending on when you had class. And it should be attached to our agenda too, if you need one. So in this problem, we've got, it's kind of a twisted around problem compared to what we've done before. Normally, what we've done before is I'll give you some function, like, I'm just going to make up a problem here, sine x. And then you're going to apply a bunch of transformations to it and then tell me what g of x is. And so what happens is, you pick a general point, a sine a. This is a side problem, by the way. This is not the problem we're doing. And let's say you work it out so that the new general point you get is like 3a plus 1, 2 sine a plus 4. And so then you can use substitution. I know that g of 3a plus 1 is going to equal 2 sine a plus 4. And so if I call this 3a plus 1 x, then I can solve for a, and I'm going to get, let's see, it's x minus 1 all over 3. So now I can come back over here and say, okay, if I replace this with x, then it's g of x, but then I have to replace the a with x terms, so it's 2 sine x minus 1 over 3 plus 4. So now what we're going to do is something a little different. I give you the f of x, e to the x, and I also give you the final function, and then we got to figure out how to get from one to the other. Okay, so in this one, you can come up with the general point pretty easily. It's a e to the a. This one down here, it's a little bit messier, but take a look at what we did. I kind of have to work backwards, because if I knew my general point for the final function, then I could figure out what the transformations were. So if I look here in this problem, in this case, I already have that function in this type of problem, and I need to get it to this type of function. So really the trick is to take what's that ugly x term and simplify it to a. Before we took the ugly a term and simplified it to x, now I'm going in reverse, right? I took the complicated a term, turned it into x originally. Now I'm taking the ugly x term, turning it into an a. So in this problem, the ugly x term is this one, and I'm going to call that an a. So over on the side here, I'm going to say 4x minus 1 equals a. So 4x equals a plus 1, so x is a plus 1 over 4. Okay, so now I know that if I write this as g of x, which is a plus 1 over 4, I'm going to get negative 2 e to the a plus 3, which means my general point here is a plus 1 over 4, comma, negative 2 e to the a plus 3. So this point turns into that point, and we can tell pretty easily what happens there. In order to turn a into a plus 1 over 4, first I have to add the 1 and then divide the 4. So that's a horizontal shift to the right by 1, followed by a horizontal shrink by 1/4. And then on the other side, in order to turn e to the a, e to the a into negative 2 e to the a plus 3, first I'm going to have to double it, or you could do the reflection first and then double it. That doesn't matter. So let's say first we do a vertical stretch by 2 and then a vertical reflection. And remember, vertical reflection means across the x-axis. And then we're going to go vertical shift up 3. So that's how we're going to get there. So these are the transformations. As long as you do the horizontal ones in this order and the vertical ones in that order, you're fine. You could even, put like this horizontal one there and that horizontal one there. That doesn't really matter. Okay. So that's what we've got. And then there's one more question. The point 0, 1, and 1e are in the graph of f. So that's on this graph, 0, 1, and 1e. And the question is, where do they end up on the other graph? Okay, so I know that 0 is like my a, and 1 is my e to the a in this part. And I know that it turns into an a plus 1 over 4 and a negative 2 e to the a plus 3. So if 0 is my a, then I'm just going to get 1/4 when I plug it into here. And if 1 is my e to the a, then that's going to go there, and I'm going to get negative 2 times 1 plus 3, and that's going to be 1/4, 1. Over in this one, now my general point, a e to the a, is 1e. So this is my new a and my e to the a right here on the original function, and I have to figure out where that point ends up. So if a is 1, then that moves to 1 plus 1 over 4, so 2 over 4. And then e to the a is e, so this becomes just e, so it's negative 2e plus 3, and then you could simplify that if you want to, 1/2 negative 2e plus 3. So here's what happens to those 2 points if you apply these transformations that we figured out. Okay, I hope that helps some.